Hello, welcome to today's CAD tutorial. In this exercise, we would be learning how to create a double V block, which is essential for securely holding cylindrical workpieces during machining or inspection. In this video, we would walk through the design and assembly of each part, including the base, the U-clip, screw handle, and the workpiece itself. We would also animate just like you saw in the beginning of this video. Let's go ahead and start with today's exercise. So we'll begin to create the first part, which is the base. And so new, like we've done so many times, under part create 2D and 3D objects, standard MMIPT is what we select and create. Select the 2D option. For this sketch, we want to create it on the YZ plane. We'll pick the rectangle command. Let's draw a rectangle here. We can dimension straight away using the dynamic input boxes. And so the height of this rectangle is 70. The width is 65. Press enter. Let me zoom in. Press escape to get off the rectangle command. And what I want to do next is to apply a coincident constraint to say that place this point on the origin. That fully defines this sketch. And so let me just finish it. You can also press E straight away to extrude. We want to extrude this symmetrically. The distance of extrusion is 100. The preview looks good, and so I would OK. Now on this face, I want to create another sketch. Let me pan down. We can first of all pick the rectangle command. Let's draw a rectangle here. We can apply the coincident constraint to put that point on the origin, and then dimension. The length of this rectangle is 5, and then the distance between this line and that edge is 6.5. We can pick the line command again. Let's draw this profile right here. We can also right click and restart to draw another one here also. Just follow the profile. Let's apply a vertical constraint between that point and the origin. We can right click and press OK. Choose the dimension command. Let's apply some dimensions. And so the distance between this line and that line at the base is 31.75. The distance between this line and that one is 38. The length of this line is 14. The distance between this line and the origin, we can apply 25. That fully defines this one. We would also want to project a vertical line to pass through the geometry. We would want to use it to mirror these two profiles. And so let's project that. Open up the origins. It is going to be the XY plane. You can right click and then OK. But for this line, let's just make it constructional. We can continue to dimension. And so the length of this line is 6.5 divided by 2. The angle between this slanted line and the constructional line is 45. The length of this line also is 19. And then the distance between this line and the horizontal line passing through the origin is 47.75. We can mirror now. And so the mirror command would want to mirror these profiles. Okay, we left this and that out, so I'll select that. The mirror line is going to be the constructional line passing through the origin vertically. We can apply that and done. The sketch is fully defined. It says that down here. So I would press E straight away to extrude and select the profiles I want to extrude, which is going to be this one. But let's choose through all. So it cuts. We'll select this also, that profile as well as this, and press OK since the preview looks good. Next, we would want to create the cutout right here in the middle. So let's create a 2D sketch let's look for a plane, which is the YZ plane. But I can't see that plane, and so I would slice. Okay. And then also project cut edges. And then pick the line command, connect this point to that point. You can right click and then OK. We would press E straight away to extrude. We want to extrude this particular profile. It is going to be a symmetric extrusion. It's going to be a cut for the boolean as well. The distance of extrusion is 36.5. The preview looks good, and so I would OK. Let's even apply some detail, and so a fillet. Let's turn this upside down. The fillet radius is 5 mm. We want to apply it to this edge and the opposite edge and press OK. Let me get the isometric view. Awesome. So now on this face, I would want to create a sketch to make a hole. You can pick the circle command with that point right there. Make sure you snap onto it. It turns green. You know you are there. So just click and drag. The diameter of this is 19. I would enter that and press E straight away to extrude. It is going to be an extrude cut for the boolean. The distance should be through all. The preview looks good. I can turn it to C and I would OK. Now we would create the counter bore hole on this face. For that, we would use the hole command. So just click on that. That opens up this dialog box. We would specify some details. The hole is going to be a tabbed hole. The seed is a counter bore. And then the type, we would select asymmetric profile. The size is 10. The designation is M10 by 1.5. The class is 6H. The direction is right hand. Make sure you turn on the full depth, and termination should be the first one distance. Now we have to specify these details. And so the diameter, which is the bigger diameter, is 12.7 mm. The height of that is 4 mm. And then the entire length of this counter bore is, let me change that to 20. Now let's place where we want to put the hole. So we would click here. And once you touch on this edge, it allows you to specify that length it should be from that line. So we'll specify 50. We would also touch this baseline so we can specify the height of the center of that hole from that edge, which is 31.75 divided by 2. Okay, the hole has been correctly placed. The preview looks good. And so I would, okay. We would want to create another hole on this face. So let's choose the hole command again. And let's specify the details. The hole type is a tabbed hole. The seed is going to be none. The type is asymmetric profile. The size is 10. Designation M10 by 1.5. The class is 6H. And what we would want to do is to place the hole. You can specify the remaining details down here. The hole is going to be on this face. We can touch this edge to place the dimensions. The height of that hole from the edge is 16. We would also specify how far it is from this edge, which is 65 divided by 2, and press OK. That will be it for this part. Let me change the appearance. I will choose the color steel blue and save this. You can save it in any folder of your choice. I would save as base. Now we create the second part. And so let's open up our worksheet, standard MMIPT create. We would create the screw. And so we begin with a 2D sketch on the XY plane. We would pick the circle command, bring it to the origin. Let's draw a circle of diameter 12.7. We would enter that and press E straight away to extrude this. The distance of extrusion is also 12.7. And we would OK. Now let's turn this on this face. We want to create another sketch. We would pick the circle command from the origin again. We would draw a circle. The diameter of this one is 7.95. We would enter that and press enter. E straight away to extrude. We want to extrude this to a distance of 65. I would enter that. The preview looks good, and so I would OK. With that same method on this face, we want to create another sketch. Let me zoom in. We pick the circle command a third time from the origin. We draw a circle of diameter 5.95 and press enter that E to extrude. We want to extrude this one to a distance of 7 mm, and so I would OK. Now let me get the isometric view. Okay, this looks good. We would apply some chamfer. It is going to be the second option here that says distance and angle. And then we are asked to first pick the face. And so the face is going to be this one. And the edge, we will pick that edge. The distance is 1. The preview looks good. And so I would apply that and close this for now. Let's see, the chamfer has been neatly done. Let me get the isometric view. At this point, we can use the thread command to create our threads, but that doesn't look realistic. And so we'll create a customized one. Now, let's select a plane to work on. So we can open up the origins. We want to work on the YZ plane. On that plane, we want to create a sketch. Let me turn this around. This way is fine. I can even, okay, zoom in and slice this. First of all, let me project a geometry, which is going to be this line. I'll be using it for my dimensioning. You can right click and then OK. This line, I'll make it constructional, and we can pick the line command now. Just draw this profile right here. Connect the middle point of those two horizontal lines. You can right click and OK. Now let's see, we want to apply a vertical constraint to this line. Also a symmetric constraint between this line, that line, with reference the middle line. You can right click OK. We want to change this line also to constructional. Now we would want to apply a collinear constraint between this top line and this constructional line we projected, and then also a distance of 0.75 between those 2 points. Now the length of this line is 0.92, and then also this line is 0.685. Finally, the angle between these two is 28. That fully defines this sketch, and so I would finish this. Now I can choose the call command to create my threads. The profile has been correctly selected. It's asking us to now choose the axis. I can use the y-axis, and we see a preview of that. So the method is pitch and revolution. The pitch is 1.75 mm. The revolution is 32. There is no taper, and so it is a cut, and I would OK. Now let's see, we have our threads neatly done. Let me create the hole in the middle of the screw head. Let's choose the 2D sketch command and select the YZ plane to work on. Okay, I would slice this as well. and project this face. Right click, OK, but I would select these lines and make them constructional lines. And then click the circle command. Let me draw a circle here. The diameter of this circle is 6. And I would want to apply a vertical constraint between the center point of that circle and the origin. And then also dimension the distance between the center point of that circle and this top edge as 12.7 divided by 2. Press enter. You can press E to extrude this. We want it to be an extrude cut. The cut should go through all. The direction symmetric. The preview looks good, and so I would OK. Okay, that will be it for this part. Let's go ahead and change the appearance to any color of your choice, but let me choose galvanized. I am going to save this part as the fastener or screw. Now we would create the third part. And so we'll open a new worksheet, standard MMIPT, and create. We will do a 2D sketch on the YZ plane. Now pick the circle command. Let's draw our first circle. The diameter of this one is 62. We would even draw a much smaller one of diameter 50 from the origin and press enter. Now we'll get the line command. Let's draw this profile right here, making sure it's tangential to the bigger circle. This last line should also be tangential to the smaller circle. Make sure you see that icon there that says tangential. So we'll click and press escape. We would also pick the rectangle command. Let's draw a rectangle here. And dimension. The length of this line is 38.5. The length of this line as well is 12.5. The length of this also is 6.25. Now the length of this top line and this one is 76.5. We would dimension this also as 16 and apply a constraint to align the center point or the middle point of that to the origin. Now let's mirror this profile on the opposite side. We would need our mirror line first. So we can just project one of the planes, which is going to be the XY plane. And we would make that line a constructional line. Now we would pick the mirror command. We'll select those lines we want to mirror, which will be this, that, and that one. The mirror line is going to be the constructional line we just introduced. Let's apply that and done. Now let's pick the trim command. We want to take off some parts, so just watch and do same. That is it for the top part. Would also take off this one as well as this part and that one. Also this and then these parts. Let's apply the final dimension, which will be the length of this one, to fully define this sketch. Alright, so we can press E to extrude. Let's select the profiles we want to extrude, which will be this one and that one. We want the extrusion to be symmetric. The distance is 16 and we would OK. Now let's create the hole for the screw. So on this face, I would create a sketch. Let me pick the circle command and draw a circle from that point. The diameter of this is 7.95. I would enter that and E to extrude. It is going to be an extrude cut. The cut should go through all. I would OK. Now I would apply a chamfer The distance is 1, the angle is 45, and we'll choose this option distance and angle. Select this face and that edge. Let's apply that and also do same for the opposite side, this face and that edge, and apply that. Let's close this for now. Now we can create the thread. Let's draw the profile we would want to create into a coil. And so we'll pick the 2D sketch, we'll create this profile on the YZ plane. Let me turn this around, okay, and even slice. I would pick the line command just like we did before for the screw. Just draw this profile right here. We would apply a vertical constraint to this line and also a symmetric one between these two slanted lines with reference the middle line, and then also we would make this middle line a constructional line. Now let me project some geometries to aid in the dimensioning. I'm going to project this geometry as well as this one. Let me select the two and make them constructional lines. I would apply a coincident relationship between this corner and this line, and then also a collinear relationship between this line and that one. Now I can dimension, and so the length of this middle line is 0.92. The angle between these two slanted lines is 28. This length is 0.685. I would enter that. That fully defines the sketch. And so I would finish it and create the coil. The profile has been correctly selected. The axis, let me use the y-axis, and the revolution, we want 8 of them. The pitch is 1.75. The pitch and revolution is the method, and so I would okay. Now our thread has been neatly created. Let me apply some details, and so the fillet command, the fillet radius is 4 mm to this edge, and the opposite side, let me turn this, which will be that one. I would okay. We would also change the appearance of this to black cast. Now I would save this as the U clip. We can go ahead and create the handle for the rotation of the screw. So new standard MMIPT we will create. Now we'll pick the 2D sketch command. We want to create the sketch on the YZ plane. We'll pick the circle command. Let's draw a circle here. The diameter of this circle is 6. I would enter that, and E to extrude. We want to extrude this symmetrically. The distance of extrusion, we want that to be 50. And so I would, okay. Let's create some little knobs on these sides. And so we'll look for a plane to work on. We will open up the planes. We can work on the XY plane. We would create a sketch. I would slice this and pick the line command. Now let's draw a line here from that corner. The length of this line will be 2.5. We would press enter. Okay. Now from this point, just click and we would rotate. The radius of this is, would specify that with the dimension command as 2.5 also. We'll pick the line command again. Let's draw a line from this point, making sure we locate the midpoint here. So, okay, there it is. We'll go this way and then we connect these 2 points. Now let's dimension even to fully define this sketch. The length of this is 2.5. We click to place that and we press R to revolve. The profile has been correctly selected. The axis, we choose this axis. The preview looks good, and so okay. Now we can mirror this on the opposite side. And so let's use the mirror command. The feature we want to mirror will be this revolution we just did. We can select it from the work tree. The mirror plane, we can choose the YZ plane and OK. There we have one on the other side. Let's also change the appearance of this to chrome polished black. I would also save this part as the handle. Now all our parts are ready. Let's do a little recap. We created the base and then the fastener. We have the U-clip and the handle. Now let's begin to assemble. So we'll need an assemble template. So create, and then under assembly, assemble 2D and 3D components, we select the standard MMIAM and create. Now let's bring in the first part. So place, we want to first bring in the base. Let me open that, and I would right click and place grounded at origin. I need just one of them, and so I would press escape. I always like to change the view from here under visual styles to shaded with edges. Now we can bring in the second part. And so we get back to the assembly tab, place. The second part is going to be the U clip. We would open that. Let me drop that here and even another one right here and press escape. Now let me apply some constraints. The first one is going to be a mate between this face and that one. Let me apply that. Also this face and that one. I would apply that. And then also another mate between this face and that face. Let me apply that. And then also a flash between this face and that one. Choose the flash, but we want to set an offset distance of 10. That is moving away, so we would negate that and apply. We'll do same for the other side. So let me constrain a mate between this face and that face. I would apply that, and then finally a flash between this face and that one, but we want to offset that to a negative 10 and enter. We can close this and see neatly placed. We can't move this, neither can we move that, just like we want it. Before we go on, let's even create another part. Not really a part, but the job we would be placing in between these two faces to make this our work more realistic. And so let me leave this here and open another worksheet, standard MMIPT create. Now we want to create a 2D sketch on the YZ plane. We would pick the circle command. Let's draw a circle here. The diameter of this circle is 20. We would enter, press E to extrude. We want to extrude that symmetrically. The distance of extrusion, let's keep at 150. Oh, symmetric. This is fine, and so I would, okay. That is it, very simple. We will change the appearance of this to diamond plate. Awesome. Let me save this as the workpiece. Now let's get back into the assembly, and we would place that part we just made. And so place, that is the workpiece. We would open that. Let me drop that right here and escape. So I would apply a constraint, which is going to be a tangential one between this workpiece and this piece. Let me apply that, and then also another tangential constraint between that same workpiece and this face to place it right. Let me apply. Also, let's apply a mate between the planes. So let's open this up between the, let me look for the plane to work with, the YZ plane of the workpiece, and let's open the base too. That would also be the YZ plane of the workpiece. That place it right in the middle, and so we would apply this and close for now. Let me get the isometric view and see what we have. It looks good. You can right click here and collapse all. We will bring in another part and so place. This time is going to be the fastener. Let me open that. I'll drop one here and the other one there and press escape. Let me constrain. So concentrically this and that hole. Let me apply and do same for the other one, and so this and then that hole. Let me apply that. I would close this for now. Let me drag this up, okay, even further so I can apply another constraint. That is going to help in the drive we would be doing. We would even suppress this anyway. So constraint, we want to do that between this face and let's use that face. Let's see what we have. We can set an offset distance so it doesn't go through the workpiece. The offset distance, I think 10 will be fine. Or let me even do 15. Okay, this is good. And so I would apply that. I'll do same for the other one. So between this face and that face and the offset distance is 15. I would apply that. Let me close this and get the isometric view. Okay, so there it is. Let me bring in the handle and so place. The handle is this one. I would open. Let me place this here and another one there. I would press escape and also constrain concentrically this and that hole. Apply and do same for this one. Let me apply that and close this, but I would also want to place this right in the middle. So let me look for the plane of the fastener, which is going to be the YZ plane. I would apply a constraint between that and its handle, that same plane, which is the YZ plane. You see, if you choose your planes right, creating your constraints become quite easy for you. It's going to be a flash and I would apply. Let me suppress these so I can do same for the fastener too and the handle too. I would open up the origin, so the YZ plane, and for the handle too, that would also be the YZ plane, emit and apply. Let me close this for now, right click, and then we would collapse all. Let's see what we've done. Okay, neatly placed. We can also try to rotate this. Okay, so there we go. Now let's suppress those relationships I was talking about. So we opened it up here. Let's see. It is this one. So just click on that, right click, and choose the option that says suppress. We'll do same for the other one. Now we can begin with our animation. So we'll go to environment and then dynamic simulation. Okay, so that opens up this window for us. We want to insert a joint, and for the joint is going to be a screw joint, the component 1, we would select this edge is fine. For the component 2, we can also select this edge. The pitch is 1.75 and apply. We should do same for this one also. So the component 1 will be this edge, the component 2 will be that one, and then we want the pitch to be 1.75. Let's apply, and we would close this for now. Now let's get back here into the work tree. So for the standard joint, we see those joints placed here. For the first one, let's click on it, right click, and then change some properties. So we'll go to the DOF1R tab. We'll select the last option, edit imposed motion. We want to enable imposed motion, a velocity. Now let's change this to a constant value. We will choose the degree per second. Let me just do 1000 and see how that goes. I can change it later. I would. Okay. Let me do same for this one. DOF1R edit imposed motion. Let me change the constant value to 1000 and press OK. Now let me play and see what I have. So we'll play here. Okay, but it is not touching this, and so let me take it back to construction mode and also change this. So let me do 1100. I'll do same for this part. And play again. Okay, it's not touching it as much as I want to. You can keep on playing around with it, and so I'll take it to construction mode. Let me change that again. I'll do 1250 this time. Let me do same for this one. I'll play. Okay, I think this is fine. Very easy and simple. You can try this on your own. Let me know if you do. You can finish this dynamic simulation, and let's save this part as the main assembly of VBlock. Alright, and so that will be it for today's tutorial. I hope you learned a thing or two. If you did, kindly consider subscribing to this channel. Also do well to like this video. It helps the YouTube algorithm push it a lot more people. You can share this with your CAD friends. If you have any comments, questions, or concerns, just leave them down in the comment section below and I would address them as soon as I can. I'll see you soon with the next tutorial. Bye.